Troposphere. The troposphere is Earth's lowest atmospheric layer, extending from the ground to about 7 miles high at the equator and 5 miles at the poles. This is our everyday world, where we live, breathe, and experience weather. All clouds form here, from puffy cumulus to towering thunderheads. Birds populate this layer, with most species flying below 500 feet, though some migratory birds soar up to 20,000 feet. Helicopters typically operate below 10,000, while small planes usually fly between 10,000 and 15,000. The troposphere contains nearly all atmospheric water vapor, creating weather patterns we're familiar with: rain, snow, hurricanes, and tornadoes. Mount Everest's peak sits in the upper troposphere, where oxygen levels are so low that climbers often need supplemental oxygen. Air temperature drops as you ascend, explaining why mountaintops remain snow-covered even in summer. This layer is also where air pollution concentrates, creating smog in cities and affecting air quality for billions of people worldwide. Tropopause. This thin boundary layer separates the troposphere from the stratosphere above, typically located 5 to 9 miles above Earth's surface depending on season and latitude. The tropopause acts like a lid on the troposphere, preventing weather systems from rising higher. This creates the distinctive anvil shape of thunderstorm clouds as they flatten against this invisible ceiling. Commercial jetliners often fly right at this boundary to avoid lower turbulence while maintaining fuel efficiency. The jet stream, a narrow band of high-speed winds reaching 250 miles per hour, flows along the tropopause, influencing weather patterns and flight paths worldwide. Pilots seek tailwinds from the jet stream to reduce flight times and save fuel on long-distance routes. Stratosphere. The stratosphere extends from about 7 to 31 miles above Earth's surface. Unlike the troposphere, air temperature here increases with altitude, creating a stable environment with minimal turbulence, ideal for aircraft. Commercial airliners typically cruise between 30,000 to 40,000 feet in the lower stratosphere. A supersonic jet once flew at much higher altitude, allowing passengers to see the curvature of Earth. Weather balloons and research aircraft like the U-2 spy plane operate in the mid-stratosphere around 70,000 feet. The ozone layer resides here, absorbing harmful ultraviolet radiation and protecting life below. Without this invisible shield, intense UV radiation would cause widespread cancer, crop failure, and ecosystem collapse. With almost no water vapor, the stratosphere lacks clouds except for nacreous, polar stratospheric clouds, rare, colorful formations sometimes called mother-of-pearl clouds that form in polar regions during winter. Mesosphere. The mesosphere spans from 31 to 53 miles altitude, where temperatures plummet with height, reaching negative 225 degrees Fahrenheit at its upper boundary, the coldest natural place on Earth. This is where most meteors burn up, creating the shooting stars we wish upon. Without the mesosphere's protective friction, millions more space rocks would impact Earth's surface daily. During meteor showers, this layer puts on nature's most spectacular light shows. Strange cloud types exist here, including noctilucent, night-shining clouds, visible only after sunset when they reflect sunlight from below the horizon. These silver-blue clouds have become more common due to climate change and increased methane in the atmosphere. The mesosphere hosts mysterious electrical phenomena like sprites and blue jets, massive millisecond-long electrical discharges above powerful thunderstorms. These colorful light shows connect storm energy to the upper atmosphere. Only sounding rockets briefly visit this layer, making it Earth's least explored atmospheric region. By the way, we've mapped Mars more thoroughly than our own mesosphere. Thermosphere. Beginning around 53 miles and extending to 375 miles altitude, the thermosphere is Earth's thickest atmospheric layer, where temperatures soar to thousands of degrees during solar storms. The International Space Station orbits here at about 250 miles altitude, along with many satellites. From this vantage point, astronauts see 16 sunrises and sunsets daily as they circle Earth every 90 minutes. Despite high temperatures, the thermosphere wouldn't feel hot to human touch. The air is so thin that molecules rarely collide with each other or any object. An unprotected human would experience both freezing cold and severe sunburn simultaneously. Ionosphere. Overlapping several atmospheric layers between 37 and 190 miles altitude, the ionosphere is electrically charged by solar radiation, creating a natural mirror for radio waves. This invisible layer enables long-distance radio communication by bouncing signals back to Earth. Before satellites, all international calls, broadcasts, and military communications relied on ionospheric reflection. Ham radio operators still use this layer to communicate globally with simple equipment. The ionosphere creates conditions for spectacular light shows. Aurora borealis, northern lights, and aurora australis, southern lights, dance through the thermosphere when solar particles collide with atmospheric gases, creating swirling displays of green, red, and purple light. Space shuttle missions often flew through the ionosphere, where astronauts reported seeing ethereal light displays outside their windows as the spacecraft's passage disturbed charged particles. The ionosphere also influences GPS accuracy. Your smartphone's navigation app includes corrections for ionospheric effects. Exosphere. Starting at approximately 375 miles altitude, gradually thinning until becoming space at roughly 6,200 miles. Most Earth imaging and weather satellites orbit in the exosphere. The Hubble Space Telescope operates at the thermosphere-exosphere boundary, while GPS satellites orbit higher at 12,550 miles, still within the outermost exosphere. This region contains the geocorona, a ghostly hydrogen cloud surrounding Earth that glows in ultraviolet light. Apollo astronauts were the first humans to see and photograph this faint halo from the moon. What most people don't know is that the moon itself orbits entirely within Earth's extended exosphere. In the exosphere, gas molecules can travel hundreds of miles without colliding with other particles. Some hydrogen and helium atoms reach escape velocity and permanently leaving Earth's gravity, the only natural atmospheric loss to space. Magnetosphere. Though not technically an atmospheric layer, the magnetosphere extends from about 40,000 miles on Earth's sunward side to over 3.9 million miles in the opposite direction, a protective bubble larger than the sun itself. This invisible shield deflects deadly solar radiation that would otherwise strip away our atmosphere. Mars lost its global magnetosphere billions of years ago, causing it to lose most of its atmosphere and surface water. Within the magnetosphere lie the Van Allen radiation belts, zones of energetic charged particles trapped by Earth's magnetic field. These hazardous regions can damage satellites and pose radiation risks to astronauts. The Apollo missions carefully plotted trajectories to minimize time spent crossing these belts. The magnetosphere creates space weather effects felt on Earth. During intense solar storms, this protective bubble can compress and allow particles to penetrate deeper, creating widespread aurora displays visible even from mid-latitudes. These events can also disrupt power grids, satellite operations, and radio communications. If you liked this video, don't forget to subscribe. I'll see you in the next video.